So we've seen how powerful the linear correlation coefficient is. It shows us the strength and the direction of a linear relationship, which is lovely. It's not 100% though. I do want to stress that. There are other things you have to look at when considering whether a relationship is linear or not. But it gives us a good starting point. The symbol for it is the letter R. All right, now we need to know how to compute and interpret that value. So the following table shows the percent of students who receive free or reduced lunch prices, reduced price lunches, compared with the percent who passed the math portion of the state exam at public schools in Sandusky, Ohio. Yes, this is real data, in case you're interested. All right, now the first thing they want to know is what is the sample size? Now, at that point, it's important for you to understand what's happening in this table. So each of these rows represents a school. So there's a school, let's say school number 1, and school number 1 had 29% of its students on free or reduced lunch, which means they reach a poverty level that's so high or significant that the school will just give them lunch for free or will sell it to them at a reduced price. So school number 1 had 29% of students on that free reduced lunch program, and 66% of their students passed the state math exam. So most states have these big exams where students have to take them in junior high and high school, and the results are reported, etc. I remember taking them distinctly. So there's school number 1, 2, 3, and so on. So we can count 4, 5, 6, 7. You, of course, don't have to write this as its own column. I'm doing that for the sake of the notes so you'll understand where it comes from. And we can see there's 13 rows. So that means the sample size, the number of schools, is 13. Little n is, the lowercase n is the symbol for sample size. It stands for number. All right, now the explanatory variable and the response variable. We've already run into this a little bit in section 1.2 as well as earlier in this section. So the explanatory is on the x-axis. It's the thing that we're saying that is being manipulated. And the response is responding to that manipulation. So in general, the easy way to think of it is the explanatory will be your x, and the response will be your y. And I will stick with the algebraic convention of putting x in the left-hand column and y in the right-hand column. So x is the percent of students receiving free or reduced lunch. And the y would be the percent of students passing the state math exam. All right, so now we want to find the correlation coefficient. And of course, the formula for this is atrocious. I mean, we don't really want any part of that formula. I will show it to you just to remind you how lovely it is. You take each of the x values, find the mean for the x, find the standard deviation. It's a nightmare. So we're going to make StatCrunch do this. Okay, so the data set is actually available in StatCrunch. So if you go to StatCrunch and you click on data sets, and I'm going to try free-reduced and see what comes up. There it is, free reduced lunch. And there's the data set. Now for this we're going to go to stat regression, right? This isn't chapter 3. Chapter 4 is all about regression. So stat regression simple linear. That's where we're going to go. The x variable is what we just said, the free reduced lunch percentage. The y variable is the passing math test percentage. And then you can ignore all the rest of this and just say compute. All right, now this is usually a pretty big table, so I'm going to make it a little bit larger so you can see everything. But I have to be honest, everything we need for this class is actually from that line up. You don't even really need this one. I mean, you can have it if you want. But everything we need is in that first group, the simple linear regression results. That's all we need. This stuff is actually more advanced stuff. This bottom part actually is chapter 12, and this is chapter 14. So we don't really need any of that stuff. So all we need is that top bit right there. That's what we're looking for. And that'll be true through this whole chapter, by the way. So the correlation coefficient's right there. It's very kind of them to actually just write out correlation coefficient, which is very nice, but they have the letter right there. Now they use capital R. Don't be worried about that. Some computer programs do use capital R. I have a feeling it has to do with the computer code in the background is just easier. But it's negative 0.688. So you can use capital R or lowercase r. It's fine either way. I know what you mean. And so will your instructor. All right, so now let's write down our StatCrunch path because we're going to have to do that on an exam, I can imagine, and a worksheet and a project and various other things. So you go to Stat, Regression, Simple, Linear. That was StatCrunch. And then, of course, you choose the X, choose the Y, and click Compute. It's a pretty straightforward business. All right, now we want to comment on the type of relationship. Okay, so the type of relationship is really talking about strength and direction. So let me just kind of add that in here. So type of relationship, that's code for strength and direction, which luckily for us is exactly what the correlation coefficient gives us, as mentioned above. Right? So strength and direction. Now we have this back a few pages. Earlier in this section, there was a diagram with all the values of R. So it's back a couple pages, but it's right here. So we have it in a table form and we have it in a graph form, either way. So we want to think about our value. Well, for one thing, it's negative. It's negative 0.68. So we know we're in this bit, right, which is all three of the negative relationships, or if you will, it's over here. We know it's not perfect, and we know it's not no relation. So we're over here on the negative side of the house. I mean, technically it could be negative. Sorry. We could have no relation if it was like negative 0.1. But we have negative 0.6, which is in here. That's the moderate negative zone. Okay, so moderate negative. That's what I'll put. So let's see here. Moderate negative. And for that part, I'll say see the table or the graph, right? See table or diagram, right? The number line graph. Right? That's how you determine whether it's, moderate negative versus strong positive versus, whatever. All right. Now I want to talk about this just a little bit more because I want to make sure you all have a sense of what this means. So I didn't give a ton of space here, but I will say that you probably don't need as much space down here. So let's think about this. What we're talking about is a relationship that is moderate negative. What does that mean? I'm going to draw a picture, which we actually need for this bit anyway, so I'm just going to draw a picture down below here. So let's see this. So if we have our percent on free lunch down here, that's the x-axis, right? And then the percent on, or passing the math test, passing math exam here. A moderate negative relationship means that as free reduced lunch increases, right, as the percentage of students that are receiving free reduced lunch goes up, which means you're moving to the right on this graph, your percent that pass the math exams is going to go down. It's moderate, so it's not like, perfect, but it's going to look something like that. I obviously have way more than 13 in here. I'm expanding this idea past these 13 schools. But that's what we're seeing. This is a moderate negative relationship. Right? Okay, so now let's comment on that. What does that mean? So if we see the number of this graph below, what does this mean? This means as free lunch, technically I mean reduced lunch as well, but I have very small spaces to work with here. As the free lunch percentage increase, or the percentage, I should say, the percentage on free reduced lunch increases, let's say. So as the percent on free reduced lunch increases, right, then the percentage passing the math test decreases. In other words, as I move to the right, as my percent on free reduced lunch goes up, I move to the right, my trend is going downward. My percent passing the math test is going down. It's decreasing. So if you think of it this way, what I'm saying is, this is X, As X goes up, Y is going down. That's what we're saying.